Hey guys, how are you? I'm sure you guys are doing great. So guys, today in this video we are going to understand the routing protocol, static routing protocol, RIP routing protocol, ARGRP and OSPF. We are not going to configure. First of all, we will understand what is static, what is RIP, what is ARGRP and what is OSPF. There are some other protocols available, but only we will talk about the IGP protocol in this video. So to understand all this stuff, watch this video till end. Guys, my name is Manjit Singh and you are watching your own channel Tech Guru Manjit English. So first of all, let us understand what is routing protocol. What is routing protocol? To make you understand, let me give you an example, very simple example. Let's say we have two local area networks available. Let's say this is switch number 1 and this switch has connected with some computer. We have another switch, let's say switch number 2, and we have some computer connected to switch number 2. But wherein switch number 1, the all the computer is configured with the IP address 192.168. let's say 10.0/24 series, and switch number 2, the IP address of class B 172.16.0.0/16. So these classful IP addresses are configured on both the networks. So this is a separate local area network, right? And this we have another local area network. So if this local area network number 1 wants to communicate or maybe transfer the data to local area number 2, so definitely we cannot transfer directly. If we connect directly both the switches with the help of fiber or copper, whatever media is, so it cannot communicate directly on a switch number 1 and switch number 2. Why? Because there is a the concept of working on a local area network is based on the MAC address. So if we need to communicate these two network, we need to transfer data, we need to establish the connectivity between the IP address C and IP address of class B. So definitely we need some kind of device which work on layer 3. So layer 3, so let me take here a router. So router always work on layer 3, which is a IP based communication, because routing table, a router have a feature called routing table, right? With the help of that routing table, router actually transfer data from one network to another network. So interconnection, the one line statement of this to understand the routing protocol is the device which can which can enable the intercommunication between two or more networks is called routing protocol. We need to connect this router to both the networks. So this switch number 1, the local area network number 1, will transfer data to router, and router again it will transfer data to switch number 2, local area number 2, and this is how this complete routing protocols work, right? So now let us understand the, first of all we will understand the static routing protocol, right? So all these are under the IGP. IGP stands for interior gateway protocol, which work within the network, not outside the network, right? We will also talk about in some other video about the EGP protocol, which is the external gateway protocol. But now let us understand the static routing protocol. What is static routing protocol? If you are a network engineer, let me give you an example. Let me draw some network out here. So we have these 4 routers connected to each other, right? And we as a network engineer wants to configure all these routers, right, with the help of static routing. Let's take an example. Router number 1 have X network, router number 2 have Y network, router have, let's say, A network, and router number 4 have B network. So before configuring the static routing, every network engineer should have the complete blueprint of the network. When I say blueprint, which means you should have a complete knowledge which network is connected where and in which direction, right? No doubt on that part. Our routers are intelligent devices, but when we start configuring the static routing, they does not use their intelligence. So we as a network engineer have to define each and every parameter. Let's say we are going to configure the this network based on the static routing on router number 2. So if I'm going to configure the X network, so we also need to provide the direction. Let's say the X network is towards the router number 1. So on when we configure on the router number 2, we need to also define the direction. So X network is available towards the R1 network, right, router number 1 side. So it will, whenever router number 2 will receive data for X network, it will redirect that data to router number 1. If we are going to configure a network on a router number 2, then again we need to configure on which direction this a network is available, right? So router number 2 will receive data for a network, it will redirect it towards the router number 3. Let's take an example. If we also configure B, so B is available on a router number 4 side, but we will not configure the router number 4. We will only configure here towards the router number 3, because router number 2 have a responsibility to transfer that particular data. If router number 2 will receive data for B network, it can only transfer to router number 3. Then router number 3 have to transfer that data towards the router number 4 for B network. So that's how static routing is configured. So we are just understanding the static routing protocol and the, you can say, the just a basic understanding. Definitely we will go into more deep when we practically configure the static routing protocol in some other video, right? So if you are a IT engineer and you want to configure static routing in your network, so make sure your network is in a small what you can say small network. It should not be a medium network or maybe a big network, because the moment you start configuring on a big network or a medium network, you will get confused, because there are multiple networks available into it and you will not come to know how to configure, where to configure, which route to be configured on which direction, right? So you will get confused. So that's the reason static routing can be configured on a small network only. Now let us discuss about the dynamic routing protocols, which is your RIP. RIP stands for routing information protocol, but now this routing protocol is majorly not in use. The only reason is because this routing protocol have lot of limitations. Let me give you an example. Let's say we are configuring this network, right, with the help of RIP, routing information protocol. We have X network, we have Y network, we have A network. This is router number 1, this is router number 2, this is router number 3. But when we, because a RIP is again a dynamic routing protocol, so if you are a network engineer, you do not want any kind of blueprint of the network. You just have to, you should have only the information available which networks are directly connected to router number 1. That's all. If you are configuring on a router number 2, you should have the details of all the network directly connected with the router number 2. That's all. Once you configure the RIP, it automatically all the router will send the you can say the hello packets to one each another, right? So definitely they will automatically sync each other and they will understand which network is available in which direction and what are the routes available for that particular direction network. So they automatically manage, because as I said, the routers are the intelligent device, right? When we configure dynamic routing protocol, whether it is a RIP, EIGRP, OSPF or any other, so definitely it is going to use the intelligence of within the available between that particular device, right? So when you configure RIP on router number 1, So you just have to configure the X network, or maybe here you have, say for example, Z network. You have to configure only two networks which are directly connected with the router number one. So automatically it will advertise that particular data to networks to other, once you configure these X network and Z network into advertisement. But there are some disadvantage of RIP configuration. If you configure a RIP routing protocol and in your network, there will be a disadvantage. First of all, you cannot configure more than 15 routers. Let's say the continue, you have some router connected like this, and this is, let's consider this is your 16th network. And if you check the routing table of a 16th network, 16th router, you will see the router number one information is not available in that particular router. Why? Because routing protocol, if I talk about the characteristics, it can only advertise the data up to 15 router only. And second part, it take lot of time. Say for example, router number one, this X network is now disconnected. This X network is now disconnected, it is not available anymore now. So the routing protocol will take lot of time to transfer the information to the other routers. So that is the reason we call RIP as a slow routing protocol, even though it is a dynamic routing protocol, but it comes counted under the slow routing protocol. If we talk about the today's scenario, definitely we do not have that much time, right? So again, because this network keep a lot of time, it take lot of time to transfer data. So by that time, lot of other traffic, unnecessary traffic is for that particular X network is traveling and on the network. So that is why we do not use a RIP anymore. Right now, let's talk about the EIGRP protocol. EIGRP, basically it is a enhanced interior gateway routing protocol. As the name suggested, it is a enhanced interior gateway routing protocol. So we have some advantage, and of course this protocol is also have some disadvantage, but it is far better than the RIP routing protocol. Again, it is also a dynamic routing protocol. So if you configure on this particular network, let me say, so we have router number one, router number two, router number three, and router number four, and these are directly connected with each other, right? So EIGRP automatically, once you configure the EIGRP of any router, it will automatically, first of all, because it is a dynamic routing protocol, it will automatically analyze which network is available in which direction with the help of a hello packets. Once you configure and advertise particular networks, again, if you are a network engineer, you do not have required all the information of an entire network. So just if you are configuring on router number one, you should have the only information available, what are the direct connected networks available with router number one and router number two, router number three, and router number four. If you are configuring on a router number two, of course you should have only three networks information. One is this, let's take it as a Z, and this, let's take it as a network C and Y network. That's it, right? It will automatically shake hand with other routers. The advantage with the EIGRP protocol is the moment some network connect or disconnect, it immediately transfer that information to entire network. It automatically broadcasts this information to all the routers available in that particular network, so that unnecessary traffic cannot be generated during that particular for that particular network, right? So this is the advantage, I would say. Of course, the disadvantage is available here. Disadvantage is you can only use up to 255 routers. By default, when you configure the EIGRP, it can only send the advertisement of particular network up to 100 router. But with some command, with the help of that command, you can increase this number to 255. So if you have a network, let's say you have a network where you have a 300 routers connected directly in a straight line, so you cannot use EIGRP protocol because it has a limited only till the maximum router you can use in a straight line, that is 255. You cannot use beyond that. Of course, if you want, you can use that EIGRP, but some of the networks will not be available on the entire networks, right? So this is the disadvantage. Of course, it's also gives you a very good, you can say, the experience when you work with this EIGRP protocol, because immediately it advertise the information of a connected network or a disconnected networks. So definitely we are going to configure EIGRP as well in future videos. Now let us understand about the OSPF, right? So OSPF is a open shortest path first. So OSPF is a great dynamic routing protocol which can be used for for a big network, you can say, because there is no, first of all, the let's talk about the advantage is there is no limit to use limit okay limit to use routers. There is no limit to use router. You can use n number of routers, right? So if you are a ISP and you have to configure a network, say for example a pan India, or maybe some country level, or maybe multiple country level, definitely you can use this OSPF module, OSPF dynamic routing protocol, because it gives you a control over the entire network, right? So as I said, there is no limit of a router. Of course, let's take an example that you have multiple routers, right, connected like this. So all these router will be directly interconnected with each other, right? So if all the routers will give information, available networks with them, so the what happens is a time will come when all the router memory will get out of memory. Reason being, because if all the routers are directly connected in same network without any area, right, so it will all the router will send information to each other, right? All the entries, the routing table will be exhausted, the memory will be completely choked, right? So that is why OSPF is a protocol where area concept is introduced. As I said, there is a no limit of a router, right? So this OSPF is configured under the area concept. What is area concept? Let us see. Let's say you have lot of lot of lot of routers available in your network, because if you are a ISP, or maybe you have some a big network, right? So all the router will be connected to each other, right, like this, like this, like this. So as I said, a moment will definitely come when the complete memory of a router will be used with the to store the data of a networks available in that particular area, right? So here what we have done is we have to configure it in a area concept. So let's say this 4 router is considered as area, let's say area 1, and these 4 routers is considered in some other area, that is area, let's say 2. That's how area is divided. Now what are the benefits of doing this? The only benefit is the router which will connect all 2 networks together, that router have only 2 entries. One is for area 1 and another one is for area 2. That's how it can reduce the size of the routing table. Of course, the memory shortage, the issue can be resolved, right? Now let us understand, if you are going to configure a OSPF into your network, so what are the things you have to look for? So let me take an example. We have these 4 routers, and these 4 routers are configured under area 0. Area 0 is known as the backbone area. You can say it is known as the backbone area of OSPF. Why it is known as a backbone of OSPF? Let us take another example. Let's say these 4 routers are into area 1, and we have some another area which is called, let's say they have this area also have some router, and this area is, let's say it's a area 2, and we have some area out here this side. So these are also connected to each other like this, and this is your area let's say 3, right? So if I directly connect with area 2 and area 1, these all area will not communicate to each other, because these standards and the procedures and as are defined each and every normal area other than the area 0. All the other areas configured in the OSPF is considered as a normal network, right? Normal areas, regular areas. So if you want normal areas, regular areas to communicate each other, your data should always be connected, or you can say redirected by the backbone area. So all the regular area directly connected, they should have a direct connectivity to area 0, so that the data from area 1 to will transfer to area 0, and area 0 will transfer that particular data to area 3. Even if you connect directly area 1 and area 2, it will not communicate, the data will not communicate. In case if you want area 1 and area 2 to communicate, you should have a direct connectivity to router number area number 0. So area 0 is only the area in the OSPF from where entire data communication can be done, right? So let's say we have some kind of router out here. This router is connected between the area 1 and area 0. So this router will known as ABR. ABR stands for area border router, right? So even if I connect these two normal regular areas, and this router is configured under area 2 and area 1, but still this router cannot be considered as ABR, because it cannot establish the communication between router area number 1 and area number 2. So that is why while configuring or the implementing the OSPF network into your network, you should understand all the concept of this area. So each and every normal area have direct access to area 0, because area 0 is known as your area. Area 0 is known as a backbone to OSPF. So all the data will only can be transferred via area 0. So these are some basic information. It's the information which I have shared today in this video. It's not that advanced, but to make understand those people who are really wish to start the you can say the career into IT field, they should have a basic, very basic knowledge about the IGP protocols. But in coming futures, definitely one by one we will configure all the routing protocol. We'll understand how static routing is configured, how RIP configured, how ERGRP is configured, and how OSPF is configured. Of course, when we will configure the OSPF, we will take care of the area concept. I will show you practically which whatever I said, the two regular area cannot be connected together. If we, even though we connect, it will not communicate each other, right? So that's all for this video, guys. I hope this video will help you to just make a basic understanding of IGP protocols. Definitely we'll move towards the advance in our next video. So if you like the video, if you like the content, do like, do subscribe, and do not forget to press the bell icon, so that Whenever I upload a new video or I come live on this channel, you will get notified. That's all for this video, guys. See you in the next video. Till then, stay safe. Goodbye.